Okay, let's pick up where we left off. Again, that Appendix B standard normal distribution table for p-value of 0.71 having a probability of 76.11%. So this is what that looks like, and this is a image capture from Appendix B of our text. These JPEG files for both positive Z values and negative Z values are in Canvas under our module for this chapter. So in this case, Z value of 0.71 is the intersection of this. First find the first significant digit, the tens place, if you will. 0.7 is this row. Then we look across to the hundredths place. 0.71 would be this column. Therefore, 0.7611 or the probability of 0.71 is this value, 0.7611. Make sure you've got this from your textbook, or you have printed a copy of the JPEG files that I've posted in Canvas for these appendices. You'll need them to refer to answer these types of questions. All right, I've given you a couple more practice problems associated with the uncertain activity times. I've given you these values. This is the network diagram completed, and I've given you the A, M, and B values, and I'm asking you to answer some questions associated with that. I've given you the practice problem, the answers for T and the variance, remembering that when you're given these values of optimistic and most probable pessimistic and so on, you can use this file titled Uncertain Activity Time Calculations, enter the A, M, and B, and the expected time, T value, and the variance will be calculated for you. If you enter them properly, then you will get those values and you can get these outcomes. Then in this case, this is probably more a little crazy with regard to the hundreds or the tenths and hundredths place values that I'm going to give you in a test. I won't go to that level of granularity. I'll try and keep them whole numbers or 1.5s and so on with the forward pass and backward pass. But this is a tougher one than you probably will experience for a test. And again, I've given you here the answers for the critical path activities, and with regard to the calculation for probabilities. In this case, we get the targeted or question completion time of 28 days minus the expected completion. So this is asking us what's the probability of the project completed in 28 days versus the expected of 29. So in this case, we take 28 minus 29, we get a negative value. And then we have to use the associated Appendix B table from where negative Z, negative 0.82, we get 0.2061 or 20.61%. All right, now another uncertain activity time, practice problem. And no, this is not uncertain, forgive me. These are certain activity times. Again, asking you a certain question will be completed by a certain date, and yes, in this case, is the answer. You should be able to work through that yourself. Here's another one, number 5, and again, I'm giving you the answers. These answers files are also in a PDF file I've put on Canvas. Every one of these practice problems, numbers 1 through 5, are in a PDF file that will be easy to follow. I've posted in Canvas. All right, so the third topic for this chapter, project crashing. Let's define it. It's a method for shortening the project duration by reducing the time for one or more critical path activities to something less than its normal time. That is, can we reduce the duration of an activity on the critical path? Only does any good to shorten the duration of the project if you're going to shorten the time for critical path activities. If you shorten the time for something with slack, it's possible that it won't have any positive effect on the project in terms of shortening the duration. This usually means that you have to apply more resources, people, money, tools, etc., etc. And again, because it's added cost, we would only want to identify the critical path activities that cost the least to crash, and then only crash them the minimum amount necessary. We also assume that we can crash a portion or only a fraction of activity. Let's say we only need to shorten something by 1 day, but we can conceivably crash it or shorten it by 2 days. We assume that we can take only 1 day. So we're going to do a manual trial and error approach. We're not going to consider a revised network diagram and so on. Okay, so when we do this sort of thing, we identify the normal time and the cost associated with something. This cost variable is new to us. And the crash cost. Now notice here that step A, in terms of a set of activities here, normal time would be 6 units, whatever they are. The crash time would be 5. We're getting 1 week out of it. But it's going to cost us $20,000 more to get that additional week. Let's look at what that might look like. So activities A through I, we've identified those activities on the critical path, the normal time and the normal cost, crash time and the crash cost. Time reduction, TR, is the normal time minus the crash time. In that case, we can get 1 week. And what is our crash cost per unit of time? In this case, it's weeks. So we take the crash cost minus the normal cost minus the time reduction. We get a calculation. So if I were to ask you to reduce the project duration by 2 weeks, which activities would you crash? Again, we only should bother looking at those activities on the critical path, in that case identified by the asterisk. So if we want to get 2 weeks, H would cost us $350,000 to get a week. It doesn't really seem attractive. We can get 3 weeks out of F if we want, but it's going to cost us $60,000 per week. E, we can get 1 week. That's going to cost us $70,000. Let's look at C. C would cost us $50,000. It's a little better. A, get a week, costs us $20,000. That really seems like a great candidate. Let's work on the presumption that we should take a week out of A, but we're being asked to reduce it by 2. So that gets us 1. Now we have to decide for the remaining activities which would be the most economical. Certainly not the $350,000. This would be the remainder between $50,000, $60,000, $70,000. We'll choose the $50,000. That's certainly the most economical. We'll crash activities A and C each by 1 week in order to obtain the 2 weeks. And that's going to cost us an additional $70,000 to complete the project. All right, I'll have a simple question related to crashing on the test, more conceptual and very little in the way of calculations. Please try the Chapter 9 practice problems. Please write to me if you've got any questions, if you've got any challenges. The practice problems will be similar to that which you'll have to do in the test for Chapter 9. And I hope you found this topic interesting and useful. Thanks very much. Have a great day. Bye-bye.